Okay, so the questions that look like this, the trick really lies in reading the question and making sure that you state things very obviously. So a spherical balloon inflated such that its radius increases at a constant rate of 3 centimeters per minute. So we're going to start noting some stuff down. First thing I'm going to do is spherical as a balloon. So we need to turn to our menstruation section of your formula booklet. We're going to look for the volume of a sphere. So volume equals 4 over 3 pi r cubed. It's inflated, which means it's going to be increasing, such that the radius, so the rate of change of the radius with respect to time is given as 3 centimeters per minute. Now, the trick for writing this out is by looking at the unit. So it's centimeters over a unit of time, which is how I know that it's going to be dr over dt and not the other way around. If it was decreasing or deflating, then there would be a negative in front of this, not a positive. Determine the rate at which the volume is increasing. So we want the volume is increasing when the radius is 5 centimeters. So radius equals 5 centimeters. Determine the rate at which the volume is increasing. So that'll be dV with dt is what we want to find. Okay, cool. So now we can look at what we've got. So we've got dr over dt. We want dV over dt. So let's start setting up some equations. So dV over dt is going to be equal to dr over dt. Now I need to think about what I have to multiply this by to get that. Now what I need to multiply it by is going to be dr over dV, and I know that because if I cancel these out, I'm left with that. So that is our objective here. So next thing that I need to calculate the derivative of the volume with respect to the rate. So let's just do that calculation down here. So dV over dr is going to be equal to 4 over 3 pi times 3r squared. So that's going to cancel with that one, and I'll be left with 4 pi r squared. Okay, so now I can start filling this stuff in now that I'm sure that everything's around the right way. So that was 3 times 4r squared is going to be 12 pi r squared, and now I'm going to multiply. I'm going to use this information when the radius is 5. So we're going to let the radius equal 5. dV over dt is going to be 12 pi times 5 squared. So that's going to be 12 times 25. Just do a little sum to the side. 60, so 0, 2 times 4, this times this 2, so it'll be 300. So 300 pi is going to be the rate of change with the volume with respect to time when our radius is equal to 5 centimeters. Now the correct unit that we're going to put on that is centimeters cubed per minute. Don't forget units on these questions. They will cost you a mark if you don't put them in.